Good day students. Today we will study about electric current and the topic is how to find out the equivalent resistance of combination of resistors. Now when we talk about the combination of resistors, so generally there are two kinds of combination of resistors. Now look at here. Combination of resistors are drawn with this diagram, right? There are two kinds of combinations, series combination and parallel combination. Means two resistors can be combined like this, so we will call that they are connected in series combination. And on the other hand, if the two resistors or more than that are connected like this, look at the diagram, so then we will say that the combination of resistors are parallel combination. Okay. Now, what do you mean by equivalence resistance? Equivalence resistance means there are two resistors R1 and R2. Now, can we replace these two resistors with a single resistor that can do the job of both the two resistors? So, that resistor will be called as the equivalence resistance of the various resistors. Similarly, as this is series and in parallel, there are two parallel resistors. So, can we replace these two parallel resistors with a single resistor that can do the job of both the two resistors in the circuit, right? Now, look at here. The next point that comes is how to identify that resistors are in series or are in parallel. Now for that there are some identifications by which we can say that yes, they are either in series or in parallel. Now for this you can understand, let's suppose we have two people. Now look at here, we have two people. Now this is the hand of one person and this is the another hand of one person. Now this is second person, he has two hands, hand 1 and hand 2. Now if you see the diagram, here what is happening? One hand is connected to the power source, that is a voltage source, and the other hand is connected with the other person, and the second hand of other person is connected to the other terminal of a power source or the voltage source. Means, let's suppose if a current passes from here, this is the power source, voltage source, the current will pass. So the current passing through the voltage source, it goes directly to the person number 1, first person, and the same current passes to the second person, right? And the same current again comes back to the negative terminal of the voltage source. Now, whenever such situation occurs, like here, you see the same condition is there. You can imagine you can replace the resistors with the person here, and similarly you can replace the persons as resistors here. Look at here. The same current passes through both the two resistors and the same current comes back to the negative terminal of the battery or cell or the voltage source, whatever you say. This can be called as power source, you can call it a voltage source, right? So in this condition, the equivalence resistance can be found just by adding both the two resistors, right? And this is the simplest way, that is in series combination. You need to just add on the value of resistors and you will get the equivalence resistance. I hope the point must be clear. Now let's talk about the parallel combination of resistors. Look at the second diagram, next diagram. Now, when both the two people, now look at here again, I want you to concentrate here. If you see, this is person number 1 and person number 2. Their hands, means hand 1 and hand 2. Hand 1 and hand 2 of one person is connected respectively with hand 1 and hand 2. Means person 1 and person 2, and person 1's one hand and second hand, they are connected with the other person's hand 1 and hand 2, like this, and finally they are connected with a voltage source or a power source, so that the current passing through the cell, it is divided into two parts. Means the current passing from the voltage source, let's suppose I is the current which is coming from the cell. Now when the current I moves from here, so when it reaches here, now there are two branches, this in which resistance 1 is there, and second branch, this branch in which resistance R2 is there, right? So the current will be divided or distributed in two parts, I1 and I2. And if you add both I1 and I2, you will get the same current which is coming from that. Are you getting? And from the other end of resistors, again the same current are added, and then the final means the sum of I1 and I2 will again come back to the negative terminal of the cell, right? So whenever this situation occurs, look at here, again the current has been divided into two parts, and both the two parts again are added and then making it the final current, and the final current again comes back to the voltage source. So whenever such situation occurs, we call this combination as a parallel combination of resistors. And how to find out the equivalence resistance? Again, the equivalence resistance means, can we replace both these two resistors with a single resistor, so that the single resistor can do the job of both the two resistors.